We're on page 156. If you guys turn back from 156 to 155, what's the title of the chapter called? Linear functions and inequalities. That's what we're going to be dealing with mostly this chapter, but do you notice this lesson is called Relations and Functions? So the chapter is relating to functions, but we're going to be talking a lot about relations because in order to understand what a function is, I got to know what a relation is. All right, so what's a relation? It is simply a set of ordered pairs. I'm going to highlight some words I want you to get for these definitions because maybe they'll help you to remember some things. It's a set of ordered pairs. How many ordered pairs need to be in a set? At least 2. So you can have 2 or more. That's going to give you a relation. I'm going to give you a relation up on the board. And I'm going to tell you certain parts that need to be there in your own relations and why they need to be there because I write it in a specific way. So what I want you to do is I want you to start off with a parenthesis, open parenthesis, and let's go with 212 and then comma 100 close parenthesis. Okay, so this right here is an ordered pair. How do I know we're referring to an ordered pair? You have parentheses that are at the beginning and at the end. What separates the two numbers? A, comma. That's an ordered pair. Okay, now, is this a relation? What do you think? Is that a relation? Is it a set of ordered pairs? No, it's only one ordered pair. So now I'm going to come up with another ordered pair. There it is. 98.6 and 37. Okay, this is another ordered pair. How do I know it's an ordered pair? It has parentheses, and then it's separated by a comma. And notice each ordered pair has to have parentheses. If you just put numbers with a comma in between, you're just talking about 2 numbers. But when you have the parentheses, you're talking about a specific ordered pair. Okay, let's do another one here. Another ordered pair, and then the last one. Okay, so the last 2 ordered pairs are 32 and 0, and then 0 and negative 17.8. Okay, are these multiple ordered pairs? Now, is it a relation? Well, it is a relation if I do this. I'm going to start off with an open bracket, and then at the very end of this set, I'm going to put a closed bracket. That now is a relation. So what I'm trying to say here is that these 4 ordered pairs relate to one another in some kind of way. I haven't described it. Does anyone know it? Or are these just kind of random numbers? What do you think?
No, I have a question.
Yeah, go ahead.
What is an ordered pair, really?
Yeah, great question. So what is like this?
Yeah.
Okay, you guys have looked at ordered pairs, but I think it's been a while. Do you guys remember drawing a coordinate plane? And do you guys remember your x and y values that tell you where you put that little dot? That's what that ordered pair refers to. And we're going to look at that toward the end of the lesson. How do you put that on a coordinate plane? But yeah, ordered pairs mean something. But I want to get even more specific because those are just numbers. Does anyone know what these numbers are? They're not random. They look random, but they're not. These are some of the most important numbers in your life. You don't even know them? Okay. Anyone know? Come on. What? That's not important. Okay, does anyone know this number?
Your temperature.
Your internal body temperature? Okay, what's 98.6? That's what you should be in Fahrenheit.
Isn't 200?
What should you be in Celsius? 37. These relate. But those are pretty random. You should not be this internally. Yeah, this is the boiling point. When you turn the water, if you turn it to 212 degrees Fahrenheit, what's going to happen to that water? It's going to boil. Or 100 degrees Celsius, it's going to boil. what happens here? Fahrenheit 32, water freezes. Celsius at 0, water freezes. That's super random. This is just another comparison. If you have 0 degrees Fahrenheit, what degrees do you have Celsius? Negative 17.8. Okay, are those numbers important, by the way? Yeah, super important. In fact, we're just talking about water. Like water with these, and then your body. Okay, your body's important, and water is also important, because what percentage of your body is water? Do you guys know? It's like 75% water. This thing right here is 70. So water weight, if you've ever heard that, that's literal water. This is 70% water. So this is important because of temperatures. But what are we comparing? Fahrenheit to Celsius. Is that ordered? Is that like an order? Or is this just like random? You know, Fahrenheit, we decided 212. I love that number. And then Celsius, we're like, you know what? 212 is so dumb. Why don't we just say 100? And that's how they relate? Or is there something mathematical about them? Mathematical. There's a formula. We're not going to look at that specifically. But do you see how these two numbers have to relate in a certain way? Okay. These are ordered pairs. And there's a set of ordered pairs which makes a relation. Okay. Fine. That's great. But I want to look at not only relations. I want to look at this term domain. And go ahead and get that definition. Domain is the set of x coordinates. You're like, what are you talking about? Well, we'll talk about it in just a moment. In a relation. We're talking about domain. And there are a lot of terms in this first lesson, but they're going to be applied to the rest of the chapter. So I would learn what these definitions are, not only for today, but also for your homework tomorrow, the next day, the day after that, the day after that, and dare I say the day after that. Okay, so what are the x coordinates? Can anyone give me an ordered pair that we already wrote? Just give me one of the ordered pairs. You can say it out loud.
212 and 100.
Okay, 212 and 100. 212, comma, 100. Do you guys remember which number is referred to the x coordinate? 212, the first number is always the x coordinate. So if I wanted to give a set of all the x coordinates in a relation, this is how I write it. You write capital D equals, and then brace, open brace. And we've seen these before, and hopefully you'll remember how to draw them. Can you guys give me, for that set of ordered pairs, can you give me all the x values in order from least to greatest? So what are the x values in those four ordered pairs? Least to greatest. What's the first one? First one, least to greatest. 0. Next one. 32. Next. 98.6. And last. 212. Close brace. That is your domain. Okay. So this is what I really need you to get. When you hear the word domain, what are you thinking of? X. You think of X. Then you're like, wait, what are you talking about X? What do you mean by X? When you're talking about an ordered pair, what's the first number? The X value, or the X coordinate. Okay, so these are all the X values. Okay, that's for the domain, but we also have what we call the range, which guess what? Is not the X values, but the... Are you guys doing okay? How many of you stayed up too late last night? Oh, is that it? How many of you are like, I didn't stay up late? I normally stay up this late. I just don't get much sleep anyway. Okay, that's fine. Okay, but should be the y coordinates. Okay, looking at that relation, what are all the y values? They're all the second numbers in each set of parentheses. So can anyone give them from least to greatest with the y values? And so you're going to put it here. R equals, open brace, and then give me all the y values. Order least to greatest.
Negative 17.8. 0. 37. 100.
Okay, is this a set of y coordinates from that relation? Yes. So that's my range. You're going to be doing this, by the way. Is this hard?
No.
I hope it's not hard. It should be very straightforward. But what you need to remember is x values are the domain, y values are the range. So R is for y values and D is for x values. All right, pretty straightforward. You have three terms you've looked at. Ready? Relation. What's a relation? You can read it to me. Set of ordered pairs. What's the domain? Set of x coordinates or x values. What's the range? Set of y. All right, how many of you are good with those three terms? Because I wish that was it. That would be easy, but we get a little bit tougher. Let's review. Look on page 157. And I need you to look at the try these section. And look at number 2. Look at number 2. It says write the domain and range of each relation. And then it asks you another question that we're not getting into. Just give me the domain and range. So I want to know what's the domain and then what's the range. And I want the values from least to greatest. Do it for number 2. Number 2, please. So they give you a relation, and then they give you, the set of, they want you to give me the set of x values and the set of y values. So you put D equals, all right. Who can give me the domain in order from least to greatest? Yes. Drew.
-4, -3, -2, 0.
Okay, so those are all the x values from least to greatest. Okay, straightforward, pretty easy. Sam, give me the range, least to greatest.
I'm so sorry.
That's okay. Look at each set of parentheses. Tell me all the second numbers and arrange them from least to greatest.
-4, -3, -2.
That's familiar. Hopefully you realize that they're the same numbers. Okay, that's all you have to do for domain. And that's all you have to do for range. Any questions on that? Okay, do it for number 1. What do you notice about the domain? They're all the same. So this is what you do for number 1. Notice I put that second. What's the domain on each one of those? This is 4. So do you write 4, 4, 4? 4? No, just write 4 once. Don't repeat values in the domain in the range. Just write it once. So domain is 4. But what is the range? So what are the y values from least to greatest on that? Number 1. 0, 1, 2, 3. And in order, that's what you got. Oh, that was awful. Okay, that's your range. That's your domain. Don't repeat least to greatest on both. How many of you are pretty, like, this is not too bad. I can do this. This will be a good chunk of your homework, but it's not everything. I know. Before I get there, look at number 3. Do you notice that they don't give you the ordered pairs in parentheses? You guys see there's no parentheses there other than in the blue or red section? Okay, who can give me the domain least to greatest there? You're like, how do you know what the domain is? Well, which one is the x value? Input or output? Input. All right, so give me least to greatest on the input. Natalie.
1, 2,
Good, that's it. 1, 2, 4. Give me the, whoa. Okay, that's input, right? Input was x. Output, what is that? What did they just write there? Input was x. But what's the output? Okay, this is something we're going to look at tomorrow. Write this down. This. And has anyone ever seen that before with the F and then parenthesis X inside? It's weird. This is how you state it, f of x. Can you guys say that with me? F of x. One more time.
F of X.
Not everyone did it.
F of X.
So that's how you read that, f of x. Hudson.
F of X.
Hagen. Jack. Darius.
F of X.
Jackson. Hannah Grace.
F of X.
Sophie.
F of X.
Michelle.
F of X.
Gracie.
F of X.
Andrew. Everybody.
F of X.
Oh, there we go, guys. Now everyone's said it. Okay. The reason I want you guys to say f of x is because a lot of people just say fx. It's not that. It's f of x. And we're going to look at that more tomorrow, but that's what we're talking about. But f of x is the output. F of x. I know this is going to seem kind of strange, but f of x can also be, it can also be just stated as y. So that output is the y value. So what's your range, Matthew, on number 3?
5, 10, 15, 20.
You just put 5, 10, 15, 20. That's your range, even though it doesn't say y, and we will talk about y tomorrow. Okay, now let's move on to our next, and really the main section right here. Another definition. And this is a tough definition. In fact, I underlined a bunch of stuff, and I realized, you know what? I need to underline more. But I'll just leave it like this for now. That's my definition. For a function, it's a special type of relation. And then the second part is giving me what that actually means. So you do need to know it's a special type of relation because that helps me out. But then what is that specialness all about? That's kind of tough.
Yeah, the bottom part.
Yes, please, write it all. Okay. Is every function a relation? You may answer no. Is every function a relation? Is every function a relation? Yes. Every function is a relation because it's what kind of relation?
Special.
Special. Okay, it's a special type relation. Is every relation a function?
No.
Is every relation a function?
No.
Here's a tough question. Is every relation a relation?
Yes.
Good. Is every function a function?
Yep.
Is every function a relation?
Yes.
Is every relation a function?
No.
Is every relation a function?
No.
Is every relation a function?
No.
Is every relation a relation?
Yes.
Look at that. Sharp. Is every relation a function?
No.
But is every function a relation?
Yes.
All right. So you guys got to make sure you understand what it means to be a function relation. Okay. We get the specialist part. That second part, man, this definition is specific and it is accurate, but it's kind of confusing when we apply it. Each element of the
Domain.
What do you think of when you think domain? What values are you thinking of? X values. Please remember that X values is paired with exactly one element of the range. What are you thinking of range? Okay. How many of you get that? How many of you think you get this? Be honest. If you're like, I get that, come on. Okay, all right, it's fine. Now we're going to apply it because it's tough. Did I say every element of the range is paired with exactly one element? Excuse me, let me say that again. Did I say each element of the range is paired with exactly one element of the domain? No. If I did say that, I would have written that here, and that's not the case. So please remember this because now we're going to apply it. Look at this first relation, and I think this was number 1. So we're just looking back at it. And then this was number 2. And I'm actually going to start with this one right here, 1, number 1. Okay, look at your domain. What's your domain up here, guys? You already wrote it down, so you should know it. It says 4. What's your range? Least to greatest? 0, 1, 2, 3. Okay, so we got those. This is what I'm going to ask you, and I need the answer yes or no. The number 4 is part of the domain or range? Sorry, this is not yes, sir. It's going to get there. It's the domain. This is the range. Domain, range, domain, range, domain, range. Okay, is every domain value paired with exactly one range value? Now let me ask you this. How many domain values are there?
1.
There's only 1. I know it's 4 times, right? 4, 4, 4, 4, but what is 4 is just one number. So it's actually one domain value. And I put it this way. How many partners does 4 have? 4 has a partner of 0, but it also has a partner of 1 and 2 and 3. Does 4 only have one partner? No. Is it a function or not? It is not a function. Okay, I'm going to back it up and I'm going to see if you guys can get this. This up here, is it a relation? Yes, because a relation is a set of ordered pairs. So it is a relation, but is it a function? Is every element in the domain, which is only 1, paired up with exactly one element of the range? No, because what does 4 pair up with? It pairs up with 0 and 1 and 2 and 3. So is 4 only paired up with one thing? No. Look at this one down here. What's the domain down here? Henry.
0, 1, and 3.
Good. 0, 1, 3. 0 repeats right here. Is every domain, 0, 1, and 3, paired with exactly one range value? So let's see. Is 0 only paired with one other thing?
Uh-huh.
No.
Ooh, I hear 2 answers and you seem semi-firm on that.
Yeah.
Is 0 only paired with one other thing? Who says yes, it's paired with only one other thing? Who says no, it's not paired with only one other thing? You don't see that? Okay, what is 0 paired with? 3. Is it paired up with anything else?
1.
0. This domain value, is it only paired up? Okay, what about 1? What is 1 paired up with? Okay, is it only paired up with one other thing? Is 3 only paired up with one other thing? Function. This is a function. There's a difference between the two, and we're answering the same question every time. Okay. Look at number 3 on page 157. There's that chart we looked at. Is that a relation? Go. Yes, it's a relation. Why? Because it's a set of ordered pairs. Even though it's not written, you can tell 1, 5, 2, 10, 1, 15, and 420. But is that relation special? Is it a function? Somebody tell me why or why not, because some people are doing this, some people are doing that. Darius, you said what?
No.
It's not a function? Okay, why not?
Because 1 is paired up with 5 and 15.
So does the domain value of 1 only have one partner? It has how many? 2. Remember my definition? Exactly 1. So that is not true. Number 3 is not a function. You're right, not a function. How many of you are okay with that? Any questions on that? Yes, sir. Hudson.
What if like 15 was like 5? Would it still not be a function because of f of x?
Okay, so if the same problem, but instead of 15 you put 5?
Instead of 15 there was like 5 there.
Just a 5. It would be a function because look at 1 is paired up with 5, and then 1 is paired up with 5. So isn't 1 paired with the same number?
Yeah, but I thought it should always be a range, like f of x. Like, is that a range?
Yeah, because f of x really stands for y. It's another way of saying y. I know that's kind of tough, but yes, it's still the range. Good question there. Okay, you can do it with numbers, but you can also do it with graphs. All right, give me a coordinate plane, And you're not going to do these on your homework, but I just want you to get practice because you will do them this week, and it will matter how you do it. So go ahead and give me the y-axis and give me the x-axis. And then we're going to practice graphing a little bit and then seeing, is something a function or not? Is something a function or not? Okay, when you draw your coordinate plane, do your best to try to make it as neat as you can. It doesn't have to be perfect. Like I'm looking at my line, it's not even straight. That's okay as long as I'm trying to make it straight. And then your tick marks should be as evenly spaced as you can. You could take forever and like measure it out, try to get evenly spaced. You don't have to do that. Just try to do it by hand, by the eye test, but don't get sloppy. So this is not what I want to see when you're drawing your line. That's awful. You went way too fast, and maybe not to you, but it shows that it was too fast and a little bit sloppy. So be a little bit neater on that. Okay, what I want us to do is we're going to practice putting ordered pairs on a coordinate plane. What's this axis called right here? X-axis. What's X referred to? What's another word for X that you're thinking of? Domain. What's this axis right here? Y-axis. So you're thinking of what? Range. Good. Okay, here are the ordered pairs I want you to put up. And then later you're going to tell me how to do it. You're on your own. The first one I want you to put is 0, 0. So that's right at the origin. That's where 0, 0 goes. And then if you can, put -2, -2 up there. -2, -2. That ordered pair, -2, comma, -2. So like, how do you do that? Starting at the origin, where do you go for -2? To the left 2, and then you go down 2. That's -2, -2 right there. And you always go left or right first, then up and down when you're just putting a point. And that does change in a little bit, but not right now. Okay, and then put -3, -3. Who could tell me where to put -3, -3? Starting at the origin, where do I go? -3, -3. I go to the left 3, and then down 3. So I'll put another big dot there. I'm going to erase the little dots because I don't want you to think those are points. They're just my work. Okay, and then where would I go for -4, -4? Starting at the origin, I go 1, 2, 3, 4 to the left, and then 1, 2, 3, 4 down. And again, I'll erase my work. Okay. Now, some of you may be looking at this and saying, okay, I kind of get where the dots go. Is this a relation? What's a relation? A set of ordered pairs. Is that a set of ordered pairs? It is, even though you didn't write it. What's this ordered pair right here? What's this ordered pair right here? This one? And this one. Yeah, it's a set of ordered pairs. It's a relation. By the way, almost all of them are going to be relations. There are some that are not, but don't worry about those. I want to know, is it a function? Do you guys remember what the answer was to this? We already did this one, by the way. You guys, stand up, everyone. Stand up. Feels like a spring day, and you guys are sad to be inside. I feel bad for you. Stand up. Sorry, if you need help, I'll come prop you up. Okay, this is what I want you guys to do. I want you to reach in front of you as far as you can. Just reach out in front of you. As far as you can. That's as far, really? That's it? Yeah. There you go. Thank you. That's it. There you go. Both hands, both hands. Don't look like zombies either. Like, oh, yeah, I did it. Okay? Then I want you to reach as high as you can. Don't hurt yourself. Nice. Look at that. Man, where's that? Okay. And then I want you to stretch like that. Just stretch real quick. Just kind of get a little stretch going. Oh, there are the smiles. They're coming out now. Look at that. Oh, wow. Life is not that bad. All right, take a seat. That was my beginning stretching class. I don't want to go to intermediate or advanced. I really don't. Not for your sake. Okay. Is this a function or not? We already did this problem. Is it a function or not?
Yes.
It was a function. But if you didn't know by the numbers, you can know by the graph. You can know by these points. Okay, I have here a ruler. But it is standing up and down as perfectly as I can get it. And therefore, right now, it's a vertical line. Do you guys know what a vertical line is? Okay, like jumping a vertical is how high you can jump from the ground. Okay, this is a vertical line. You guys okay with that? Okay, a vertical line can be a ruler. It could be a pencil. It can also be imaginary. I know, it's tough to think. But you're trying to use a vertical line to help you determine if this is a function or not. So this is what we call the vertical line test. Okay, I'm going to take my vertical line and I'm going to run it across my graph. The vertical line test will determine whether it's a function or not. And I'll tell you if you could determine it, with our first example. All right, vertical line. Is this vertical line ever going to hit more than 2 points on this graph? What do you think? So I have 4 points. Is it ever going to hit is it going to hit 2 or more at the same time?
No.
Ever? No, right? It passed the vertical line test. If it passes the vertical line test, you know what I know about these 4 points? They make up a function. Okay, that's the vertical line test, automatically a function.
And if they do?
And if they, for example, if this vertical line hits 2 or more at the same time, it fails the vertical line test, and guess what? It's no longer a function. Is it a relation though? Yes, but not a function. Okay, that passes that test. Let's do another set of ordered pairs here. 4, 0. Put 4, 0. Do another one. Do another one. And don't be sloppy with it and just start drawing scribbles and hoping that Mr. A will accept it. No, for your own good, make it as neat as you can without taking too much time. I know that's a balancing act. Yeah?
Like if you do the negative, would it go to the left and then positive would go to the right?
The first number.
Yeah.
The first number, if it's negative, left,
Yes.
positive, right. Mm-hmm. Second number, if it's positive, you go up. If it's negative, you go down. And that's always how it works, thankfully. You know why it works that way? As much as you don't like this, what do we call those two numbers with parentheses and a comma between them? We call that an ordered pair. You know why we all get the same points if we do it correctly? Because we're using ordered pairs. What if this side of the room thought it should be like that? We thought it should be the other way. Are you going to get the same points? No. And then we're just getting different graphs and hoping that we get the right answer, which won't happen. Okay. This is a blast from the past here. Does he need more?
Oh, no.
Okay, that's fine. All right. Get me 4, 0. Where do I go? Sophie, 4, 0. Starting at the origin.
Go to the right.
1, 2, 3, 4.
And then if it's 0, you stay on the line.
Yep, I don't go up or down. I have to stay right there. That's 4, 0. Get me 4, 1. 4, 1. Michelle, where do I go? How do I get to 4, 1?
Go to the right.
1, 2, 3, 4. So,
Up.
gotcha. You're testing me. I get it. Eva, get me 4, 2.
Go to the right. And then to the 4. And then go up.
All right. And Sam, get me 4, 3.
Go over 4. And then go up 3.
Okay. So that's where your point should be. Is that a set of ordered pairs? What do we call that? Automatically, it's a relation. Good. What are we going to do with this vertical line test? Determine if it's a function. So let's see here. Vertical line. Failed right there, right? Isn't it hitting more than 2 points? I should say more than 1 point. It's hitting 4 points in this case. It fails a vertical line test, and guess what? It is no longer a function. So you put not a function. Not a function. Oh, wait. Didn't we do this one already? How many of you remember these coordinates? Do this, everyone. You should remember. What did we say about these ordered pairs? Do they form a function? No. And it also shows with the vertical line test. How many of you are good with the vertical line test? You know what it means? Okay. Passes, it's a function. Fails, not a function. Okay, look on page 157.
Is there a horizontal line test?
No horizontal line test. Which makes it easy because there's only one vertical. Okay, in the middle of the page, you guys see those graphs A, B, C, D? Okay, one is a line. It's kind of like this one, but this is what happened. Okay, this one is a little bit different because how many points are on this line? On A? How many points? Think of a line. How many points make up a line? I'm trying my best, but I'll never get it. How many? Infinite, right? Okay. Is it going to pass the vertical line test? Let's check it out. Yep, it's going to pass because it's never going to hit more than one at the same time. So A, is that a function or not a function? It's a function. Okay, what about B? Check B out. Why is it not a function?
Because it hits more than two.
It hits more than, I'll say it clearly, more than 1 point at the same time. Yep, so B is not a function. C! Ooh, I like C. Function or not a function? Why is it a function? Yeah, it doesn't hit more than 1 point at the same time. What about D? Not a function because it hits more than 2 point. All right, wow, more than 1 point. It hits it actually several times. So D is not a function. Did you get how to determine the vertical line test? Vertical line test is very easy to use. That's why we go through it. Okay. Wait, that cannot be it. Okay, we're not done with the lesson, but I'll give you your homework anyway for the first part, and we'll finish it up tomorrow. You need to know these definitions. Relation, domain, range, function. 4 of them today. I know, that's a lot. And there's your homework. 8 to 22 even. Pages 175 and 176. It's time for me to go.